All right, guys, welcome to Math Analysis. We are starting a brand new unit today. We're talking about stoichiometry, otherwise known as molar mass, molarity, whatever you want to talk about. It's chemistry, right? It's really cool stuff. I love this stuff. I know this is a pretty far cry from derivatives, but honestly, we covered what I wanted to with derivatives. There was a lot of that packet that we didn't do, but that's okay, because I kind of created that packet in a little bit of a rush on our last day of school there. So plans changed, plans evolved, but I'm really excited for us to be able to close out the year working on this because I love this topic. So first off, a couple of things. If you were able to pick up the packet on Monday, you should have this, what you see in front of you. If you were not able to pick up the packet on Monday, then it is located on your Google Classroom right below this post. You'll see it right there. Now, the one thing I tragically forgot to put in your folders is a periodic table. I meant to do it and it just slipped my mind. So that is in your Google Classroom. You can also just Google search a periodic table. I'm sure you can bring up an image of one online. You can find it in Google Classroom. If you still have the print off from whenever we talked about this in class in March, you can use that one. I'm going to be utilizing the periodic table on the calculator here, at least for now until I get back into the school and I'm able to print me one off for the videos. So what we're going to be talking about is molar mass, right? Now, if you recall, way back when, we talked about the term moles. And we said moles is the number of atoms that a mole is the number, a group of atoms, 6.022 times 10 to the 23rd, Avogadro's constant, and its mass is equivalent to the atomic mass of the element, but in grams. So here's the deal. Way back in the day, right, the scientist Avogadro, he concluded, every element has a mass to it. So I'm just going to choose lithium here. And I'm going to say, okay, lithium has this weight. It's labeled as, and I'm going to call it mass. That's a much better word for it, of 6.938. Now, this 6.938 is technically in AMUs, atomic mass units. That's the tiniest fraction of weight in the world, because it says this single lithium atom weighs 6.9 AMUs. Now think about how small an atom is. It's impossible to think about how tiny that is, right? And you got to think about how much that tiny little thing weighs. It weighs nothing, right? Pretty much. But it's 6.9 AMUs. Now, usually whenever we talk about mass, we're talking about grams. So Avogadro says, right, that we could have 6.9 grams of lithium. To have 6.9 grams of lithium, he's like, well, how many lithium atoms would we need to have? We would need to have a lot of them, right? Because if this is just the most minuscule object in the world, but you want it to actually weigh 6.9 grams, that's, just to give you a comparison, it's about like 7 paper clips. 1 gram is about a paper clip, right? So imagine holding 7 paper clips in your hand and saying, well, that's all lithium. How many atoms are there? So Avogadro made this amazing discovery. He found out that every element, not just lithium or hydrogen or oxygen or whatever else it might be, he discovered that every single element, if you had 6.022 times 10 to the 23rd of them, and if I wrote that out as an actual number, it would go all the way across the page, huge number. If you had that many of them together, then its mass would be equal to its AMUs, but in grams. So if you got together that many lithium atoms, it would weigh 6.9 grams. If you got together that many hydrogen atoms, it would weigh 1 gram. If you got together that many, I don't know, let me choose a random one, argon atoms, it would weigh 39.9 grams, right? Like, it was this amazing discovery that this amount of atoms makes that group equivalent in mass to its AMUs, but in grams. So whenever we're talking about molar mass, and this number, Avogadro's constant, is considered to be a mole of atoms, or a mole. If you have that many of something, you have a mole of it, right? It's like saying if you have 5,280 feet, then you have a mile. Well, if you have 6.022 times 10 to the 23rd, you have a mole. That's how it is. So the idea is that when we talk about molar mass, we are talking about having a mole of this element or of this molecule or of this compound, and how much mass would that have? So we measure it in grams. Molar mass is all in grams. I'm going to put that up here. But if we have a mole of this substance, then all we have to say is, well, a mole of chlorine is 35.4 grams. A mole of oxygen is 15.99 grams. A mole of nitrogen is 14.0 grams. That's all it is, right? That's all molar mass is. It gets a little complex. Not complex even really, but we got to think a little bit more about it when we look at some things like we have on this worksheet. Cl2, KOH. These are compounds, right? These are elements that have formed bonds with each other to create new molecules. Compounds, right? Think about compound words. Cannot. You combine it into can't. The two words form one word, right? That's what happens with these elements. Chlorine bonds together to make Cl2, which is just another chlorine molecule. Or we have KOH. I'll be honest, I don't know the name of it. It's been too long since I've taught chemistry to have all these memorized. It's been a year. I probably should, but I don't. But what we can do is we can think about this logically. We can say, okay, if this molecule is Cl2, and this subscript tells us how many there are of that element, then this element has two chlorines to it. So logically, how much mass should it have? Well, it should have the mass of 2 chlorines. So let's find out how much chlorine has its mass being. Well, it says here that a mole of chlorine would be 35.446 grams. For the purposes of this project, I'm fine with us just rounding to the tenths, just so you guys know. So I'm going to say 35.4. So a single mole of chlorine is going to have 35.4 grams. But let's go ahead and see what all this is made up with. Well, it's Cl2. So there's 2 molecules of chlorine. So there's a second one, another 35.4 grams. So for me to find the molar mass of this entire molecule, I have to add together every part of it. So the first chlorine, 35.4, the second chlorine, 35.4. Together, that is going to make 70.8 grams. So the molar mass of Cl2 is 70.8. We can do that same thing with number 2 here, KOH. How many elements are there? You're right, there's 3. There is K, potassium, O, oxygen, H, hydrogen. So to find the molar mass of all of this molecule, KOH, then we need to find the mass of potassium, the mass of oxygen, and the mass of hydrogen, and we can add it all together. So let's do that. We have potassium somewhere in here, right? Let's see, where's it at? There's it at, number 19. Sorry, my cats seem to be fighting in the background. Apologies if you can hear that. So potassium, it has a mass of 39.09. So rounding to the tenths would be 39.1. All right. Oxygen, number 8, has a mass of 15.99. Rounding to the tenths, that would be 16.0. And then we have hydrogen, the first element, with a atomic mass of 1. So if we want to find the molar mass of KOH, then we add all of the individual parts together. 39.1 plus 16 plus 1. Well, 16 and 1 I know is going to make 17. And 17 plus 39.1 should be 46.1. So all of these individual elements together, I said that wrong, didn't I? It's 56.1. My bad. All of these individual elements together make KOH, this molecule, have a molar mass of 56.1 grams. So here's what I want you guys to try out. Try out these next 4, right? See what you can do with those. What I would recommend doing is labeling exactly what elements it's made up of and how many there are. So like number 3 has a beryllium, and then it's Cl2, so it's 2 chlorine. So a beryllium, chlorine, chlorine. And I would just write down the mass of each and make a big addition problem. That's what I do personally, and I think it's the easiest way to go about it. If you have any questions on this, email me. Otherwise, try to do these 4 problems, and we'll check in tomorrow, see how it goes, and I'll see you guys then.